Tests for convergence, part 3, the ratio test. If the limit of the n plus first term over the nth term as n approaches infinity is less than 1, then the series converges. If the limit of the n plus first term, that's a sub n plus 1, over the nth term as n approaches infinity is greater than 1, then the series diverges. If the limit of a sub n plus 1 over a sub n as n approaches infinity is 1 exactly, then we can make no conclusion. We would say the ratio test would be inconclusive. It's called the ratio test because we're going to make a ratio of the n plus first term to the nth term. If the limit of that ratio is less than 1, converges. If the limit of this ratio is more than 1, diverges. If we get 1 exactly, the test is inconclusive. Example. Sigma 1 over n factorial. In this example, the nth term is, as usual, what's here, next to sigma. And a sub n plus 1 means what I put a red circle around with n plus 1 in place of n. A sub n plus 1 means replace n with n plus 1. To perform the ratio test, we make the limit of the a sub n plus 1, that's the n plus first term, to the a sub n, that's the nth term, as n approaches infinity. In this example, that would be the limit of what I just wrote there, 1 over n plus 1 factorial, over a sub n, which is what I have a red circle around, and it's approaching infinity. Let's calculate this limit. That's the limit of 1 over n plus 1 factorial. Dividing by this red fraction is the same as multiplying by the reciprocal. N factorial means n times n minus 1 times n minus 2, etc. This is not forever, though. We stop at 1. For example, if I had 4 factorial, it would be this number times this number minus 1 times the original number minus 2, and we don't go forever. We stop when we get to 1. So n factorial is n times n minus 1 times n minus 2 times n minus 3, etc. Eventually get to 1. N plus 1 factorial means start at n plus 1, multiplied by the number I just wrote, minus 1 times the number that I just wrote, minus 1, times the number I just wrote, minus 1. Continue on like this until we get to 1. So n factorial is on the top, n plus 1 factorial is on the bottom. After canceling, we have the limit as n approaches infinity of 1 over n plus 1. That is, all of this cancels with all of this. And the limit of 1 over n plus 1 as n approaches infinity is 0. Which is less than 1. So by the ratio test, this series converges by the ratio test. The limit of this ratio, n plus first term over nth term, as n approaches infinity, is anything less than 1. We can say the series converges. Okay, another example. Sigma n raised to the nth over n factorial. In this example, the nth term is what's next to sigma. And the n plus first term, a sub n plus 1, is the same thing with n plus 1 in place of n. So right here, instead of n as the base, it's n plus 1. Raised to the n, instead of n, it's the exponent n plus 1. Down here, instead of n factorial, it's n plus 1 factorial. The ratio test. We calculate the limit of the n plus first term over the nth term as n approaches infinity. Which in this example is the limit of a sub n plus 1, which is n plus 1 raised to the n plus 1 over n plus 1 factorial over a sub n, which is right there, or there, n to the n over n factorial. We're going to rewrite this division right here as multiplication by the reciprocal. Limit as n approaches infinity. Above the green line, n plus 1 raised to the n plus 1 over n plus 1 factorial times the reciprocal of what's under the green line. So we have the limit as n approaches infinity of n plus 1 raised to the n plus 1 times n factorial, means n times n minus 1 times n minus 2, etc., until we get to 1. N plus 1 factorial down here means n plus 1 times n times n minus 1 times n minus 2, etc., stopping when we get to 1. And we also have n raised to the n in this denominator. Limit n approaches infinity. Well, all this, because I'm putting yellow around, cancels with all this. Left with n plus 1 to the n plus 1. Everything else on top is gone. Denominator, n plus 1. Everything in the yellow is gone. N to the n is still there. Okay, limit as n approaches infinity. Right here we have some division with the same base. The rule for dividing with the same base, like bases, is keep the base and subtract the exponents. N plus 1 minus 1 is n. Still have this n to the n in the denominator. Since these two things, n plus 1 and n, both have this exponent, this can be rewritten as the limit of n plus 1 over n, this whole thing to the n. These mean the same thing because this over here means numerator and denominator are both to the n, which is what this says. And n over n is 1, and 1 over n is 1 over n. These are the same, just performing this division, both of these terms dividing by n. And you might recognize that this actually is, we call this in pre-calculus the definition. This limit is the definition of the number e. If we have time in class, we can prove that this limit is equal to e. It's a good idea to remember that this is the number e. And by the way, this number is e, 2.7 is greater than 1. So by the ratio test, the series diverges. When the limit of the n plus first term over the nth term comes out to be a number more than 1, anything more than 1, the series, this is the series we were testing, diverges by the ratio test. The next test is called the nth root test. If the limit of the nth root of the nth term as n approaches infinity is less than 1, then the series converges. And if the limit of the nth root of the nth term as n approaches infinity is greater than 1, then the series diverges. Example. Sigma n over 2n plus 1 raised to the nth as as n goes from 1 to infinity. We're going to use the nth root test, meaning we're going to figure out the limit of the nth root of the nth term as n approaches infinity. In this example, that means the nth root of the nth term, what's here is called the nth term. Just put red around it, n over 2n plus 1 raised to the nth power. nth root of the red is n over 2n plus 1. The nth root of something to the nth power is just the something. This is equal to the limit as n approaches infinity of 1 over 2 plus 1 over n, which is 1 over 2 plus 0, which is less than 1. So similar to the ratio test, we're going to say the series sigma n over 2n plus 1 raised to the nth power converges. I said similar to the ratio test because of this, but this is not the ratio test, this is the nth root test. This series converges by the nth root test.